Greetings, I'm Mr. Gigi, and I want to congratulate all of you as we come to the end of term examinations. Some of us are taking formative assessment in technical drawing. I congratulate you and prepare this presentation to prepare you for your assessments which are on Monday. Take this presentation with the seriousness that it deserves. So I'll take you through lesson 9, sectioning, oblique cutting of solid geometry. You are supposed to do the following or to achieve the following. Identify methods of service development is a recap. Illustrate radio service development and parallel line development. That's a recap on our previous video. Look at it. We are going to define terms. Illustrate obliquely cut right cone and right pyramid using the radio line method. Illustrate obliquely cut right cylinder using the parallel line method, and solve problems on sectioning of solid geometry using radio and parallel line method. Once again, we have looked at AutoCAD. These are some of the things that we can do in AutoCAD. If time allows, you can practice on them now that you know how to work with AutoCAD. So our recap is we have the various drawings like the rectangular prism, the sphere, the cylinder, the cone, and the prism. For a prism, we are familiar with this shape. For a cone, we are familiar with that shape. So this shape, for example, in the prism, we are borrowing from orthographic projection. And also this one of a cylinder, we are just showing the top and then the lateral surface. This is the top and the lateral surface. For a cone, we are looking at it at the elevation. This is the elevation. Then we're looking at that being the bottom or the plan. The other one just shows us the prism, which has the holes. And now you can see how we are able to show that this is a hole from the end, from that plan. This is the plan. Then we have the front. This is the front, and you can see how we have indicated the hole using the various lines that we have. So the radio line method is used in the right pyramid and right cone. So radio line means all development are produced inside a cone, the true length being the hypotenuse of that cone. So we are referring to that true length. That is the true length we are referring to. Then we are referring to this particular circle. You can see we are drawing a circle at the base. And that circle, once now we form the plan, which is square shaped, then the elevation. So we draw a circle, then from this one to this other point, we join. So the moment we join this point and the other one. And then from this point, we are able to join this point, the apex, and this. So when you talk about the apex, that the plan development, the generators are drawn as if they appear from the apex. These are generators we are talking about. These lines, those are the lines we are saying that this is the apex. They all appear to come from the apex and radiate. Then we have the right pyramid service development. So for a square prism, So you can see this one. That's the most important thing from this point to that point. I mean this one. That point is of importance. Then the development is that using the slant height from that point to this, the slant height, you come to this point and then you make an arc, radius, true length. Then you can identify that this is my point A, then you have point D, then you have C, then you have point B, and then A. So that's the point. So now draw the generators. They appear as if they radiate from the apex. So the generators, you join them, but remember the spacing from A to D. So you join A to D along this curve. So that's the development, and this one explains how it looks like. Now this one has not been cut. Now when you talk about sectioning of the same, sectioning a solid or an object is cut by some imaginary cutting plane to understand the internal details of the object. The action of cutting is called sectioning. A solid in the plane of cutting is called section plane. We have typical planes and typical shapes of sections. For example, anytime we introduce a line, for example, this one shows this is a cutting plane. If we cut, for example, a cone along that, so you see, if we cut a cone, what we have is that the top is an ellipse, but the bottom is not affected. If we cut a cylinder, like in this case, we cut it, whatever we have is that we have the top being the ellipse, and this is an oblique cut of a cylinder. So when you talk, we shall examine at how we come up with an obliquely cut right cylinder, and this is the concept. So this section is just to introduce you to some of these particular concepts. The frustum, the right cone and right pyramid frustum. For a frustum here we have its top, which have been removed. But this one now is not obliquely cut, it's just cut uniformly. So the lateral surface that we have, and when you talk about the lateral surface, we are saying a shape that is without the top and the bottom, but it is open. So you see, we can have the circumference. The circumference is equal to this, the bottom circle. So that's its circumference when it's open, and then the top is equal to that. The same for a frustum of a square pyramid. We have the bottom, which is square, and we can open it along that. Then the top, again, this one is uniform. So, but this one has been cut. Actually, this illustrates the frustum. The right cone and right pyramid obliquely cut. So we cut. So the moment we cut, it's good we realize for pyramids, once you cut them, you appear with something like a trapezium. You can see here we have a trapezium at the top. But for the cylinder, we have something like an ellipse. And also for a cone, we appear to have an ellipse at the top. So those are some of the things we need to understand. So I can use this particular diagram, and you see this one is a trapezium. So this is the one we are showing. So you'll have two surfaces as your plan. This one that is shaded with sectional lines. Sectional lines, remember, shows where the cut has taken place. And then the bottom remains the square. Remember, the bottom is not affected. Then the top. So this one, if you open it, maybe you cut it along this one and then we open. At the end of the day, we are going to have this kind of a service development, whereby you can relate that this part and that one are the same, this one and that are the same, this one is that, and the one you cannot see is that. So the top again, you can see this one and this one are the same, but this one and that are not the same. So that is what we have up here. We can go to parallel method. It applies to prism and cylinders. All the generators are parallel to each other in plan and development. What do you mean? If you have this cylinder which has a top and a bottom, the lateral surface is the pi d, the curved area. Then for a prism, the generators you see they are parallel. This one and that are parallel. And this is what we have here. There are 6 to show the faces that we have. So there are 6. For a cube, if you open this net, whatever you have, you can relate that this is the top, this is the side, all these, they are the same. The right cylinder and pentagonal prism. So once you cut, actually you can see from this, if now maybe, for example, we cut this or pictorial of obliquely cut cylinder, we are going to have the following, and maybe this is where the difference comes. You can see here we're using the radial, the parallel. So you divide this circle, the bottom here, into 12. Then you join point 1 and 10, 12, 10, 3, 9. Then see where they touches this section that has been the slant length. So the moment you identify, then you can draw parallel line to this to point whereby they touches the slant height. So you draw parallel line going to infinitely. Then again, you come to this line after spacing this point and this one with, for example, 10. Then you can take the equidistance from 0 to 11 all the way, 11 to 10. You continue all the way until you go back to 0. Remember, once you open this point, 0, and you go back to 0, you have covered the circumference. So that's why you see we are reading from 0, 11, 10, all the way to 1, not 12, but to 0, because this point, once you open it, the start and the end is 0. Then you're going to space the parallel lines. So the parallel lines that you're going to space, once you space this one to this other point, you'll realize that this point joins to that. So that for that, then number 11, it cuts the vertical line, the horizontal line meets, or they intersect with the vertical line. So, and at the end of the day, as you go to the 6 points, you go to the maximum, and then it starts decreasing. So those points whereby they meet, they're the one that you're going to mark them. Then you draw them with a nice curve. This is an illustration. So I hope I have taken you through this topic of obliquely cut solid objects using the radial line and the parallel line. So I have an example for you. That's the example. You can look at it for your consumption. So these are my references. You can see them. So I would encourage you to subscribe. Is your first time, like and share. Also, you have, before you sit for assessment, I would encourage you to do the following as your assignments, as you can see, that one. Then I have some practical problems and solutions for you. So this is what I have for you. So look at it. That's the first problem and solution. The second problem and solution. The third problem and solution. and that. So that's the end. So thank you. Subscribe, like, and share. Thank you.